Okay, so read your directions. Don't do more than the questions ask you to do. So for questions 1 and 2, you're going to create a stem and leaf plot for each data set. How many of you know what a stem and leaf plot is? Excellent. All right, so who knows what the first thing that we have to do for a stem and leaf plot? What's the first thing?
You have to make a chart.
The frequency chart, right? You have to organize your data essentially from smallest to largest. You have to decide what are your stems going to be. You don't have to always start with a stem of 1. You have to start with whatever your lowest number is and whatever your highest number is. So look at this information. The information is about 30 executives reported the following number of telephone calls made during a randomly selected week. So this is 30 different executives, and this is the number of phone calls that each of them made during that particular week. What was the lowest amount of phone calls made? 3. So I'm going to circle the 3. What was the highest number of phone calls made? 58, nothing higher than 58, right? So I see a 58. So that means that I have to have a stem that includes 3 and goes to 58. So I don't have to go higher than 58. I'm definitely not going to go lower than 3, so that'd be pretty low. All of these are 2-digit numbers with the exception of a few of them, right? How would I make that into a 2-digit number? 03, right? So what's going to be our lowest stem? 0. For this particular page, you might have to add a piece of scratch paper just to show the organizational work. All of your answers are going to be able to fit on here, but your organizing, I've got to be able to see how did you get to that stem and leaf plot. So what I'm going to do is create my stems. So what stem should we have? What's our lowest stem? 0, because I'm going to take my 2-digit number, I'm going to essentially cut it into 2 pieces. Our leaves are always, with the exception of money, our leaves are always going to be 1 digit. So the stems will be 1, 2, 3, 4 digits long, but our leaves will always be 1 digit. The nice thing about if you had graph paper is you could separate your leaves nice and evenly with the graph paper. You're going to have to be careful on here because there's not a grid for you to work with, but we'll get to that in a minute. So I have to go from a leaf of 0 to what? Or a stem from 0 to what? 5. So I'm going to set up my chart, stem. This is my pre-chart, certainly not my final leaf. And I know I have to go from a stem of 0, 1, 2, 3, 4, and 5. I have to include any stems in between 0 and 5, even if I don't have information in them. So if you have one of these stems that there's, for instance, maybe there's no 30s, you still have to include it. What I don't have to include are stems that come before or after my lowest and highest stems. So then start organizing your data. If I were you, I would go along here and just start with 22. The 2 would go here, comma, and cross out that 22. Then 12. The 12 goes on the 1 stem, comma. So separate each of your leaves with commas. And then the 10 goes on the 1 stem, so I have a 0. After that, cross it out. So keep doing that until you get through all 30 numbers. So I'm going to wait till everybody has it up there. If you're not finished yet, go ahead and look up here and just finish your stem and leaf, how I have it up here, so you don't fall behind. For the ones that we do together in class, I don't mind if you're using a pen, just your notes. But when you go to finish your homework, you need to switch over to a pencil. Now, how many pieces of data did we have? 30. What should I do to make sure I didn't make a mistake? Is it easy to make a mistake on something like this? Absolutely. So what could I do to ensure that I haven't made a mistake? Because when I did this one originally, myself, on my own, I made a mistake. How did I catch it? Count your leaves. So start off with that, count your leaves, because the last thing you want to do is make your stem and leaf plot and you have too many leaves. Look, I have 31. I think I do. Oh, I counted that one. I only have 30 this time. I counted a comma as a 1. So I only have 30, so that's good, right? If I had 31, that meant I put an extra one in there. If I had 29, it meant I forgot to put one in. And so I just start to kind of go through each of the stems and count my numbers that I have. So if I have a mistake, start somewhere and start going through the numbers and see what you have. So what's wrong with this current stem and leaf plot? It's out of order. Your leaves have to go from smallest to largest. And what's the other thing you have to make sure that you do? We have to have a key. Perfect. What's another thing I have to make sure with my leaves I do? Can I squish my leaves all together? You have to make sure that every leaf is underneath another leaf. In other words, they're all nice, evenly spaced. So if you're a sloppy person, I obviously tend to have sloppy handwriting. You have to be super neat when we do our final product. I don't really care about it here. That's what's nice about graph paper is you can put each leaf in a box, but you don't have graph paper on your final thing here. So what we're going to do is we're going to set up our stem and leaf, and we're not going to forget to do our key, but don't draw your T-chart yet. Every graph that you do in this class has to have a title. What are we going to title this graph? What's that information? Phone calls of 30 executives, or phone calls during the week. We'll just say phone calls during the week. If we knew what week it was, we'd put that down. And you want to be as descriptive as possible. You don't want to just say phone calls, because it could be monthly phone calls. I don't know. It could be daily phone calls. I don't know. But there are phone calls during a week. And so now I want to put in my stem and my leaf T-chart. You have to write stem and leaf. And then evenly space out 0, 1, 2, 3, 4, and 5. Oops, I ran into my 5. Sorry. So what's great about using pencil, you can erase and redo. All right, then start organizing your leaves. So the first one's not so bad to organize. We have an 8, a 9, a 9, and a 3. So your 3 comes first with a comma, the 8, the 9, and then the 9. And those are nice and evenly spaced apart. We don't want to squish any of them because our stem and leaf can be turned sideways to look like a histogram, and we can tell by the shape of that graph what's going on as well. The second stem, the stem 1, is a little bit harder to organize, isn't it? So if I were you on this one, I would be crossing out leaves here to make sure that you don't lose any of them. So as you put them in here, cross them out and line them up nice and neatly. 0 comes first. You have no 1s, but you have how many 2s? 3 of them. No 3s, but you have 3 4s. No 5s, but you have a 6. And a 9. Hmm? Oh, I missed an 8. Oh, sorry, that's an 8. And there's a 9. Then you would go back and, especially when it's long leaves, you need to count your leaves, because I would have missed the 8, right? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 leaves. There we go. So hopefully I would have caught the fact that I missed my 8. And then your stem of 2. That 8 probably should have been a smidgy over. Ooh, I missed it a little bit. All right, and then your 3s. And then your 4s. And then your 5s. Bless you. Now, what else do we have to have? A key. You can choose anything that you want to. So let's say that I'm going to choose the 3 and the 6. I'm going to put a 3, make sure that looks like a slash and not a 1, so make it really long, and a 6, and that equals 36. That tells the reader how to read your graph. Now, they asked for just creating a stem and leaf. They didn't ask us to find mean, median, and mode, but we could, and we will in some of the other questions. All right, so number 2 is exactly the same way, but I'm going to get you slightly started with number 2 because it is dollars. So make sure that you have a title with that. Let's talk about our stems. You don't want your stem to be 3 and 4, do you? Because that would leave your leaves as 2-digit numbers. We really don't want that. So what is your lowest dollar amount on this one? $3 and what? 71, right? No lower than 71? That looks about right. What's your highest dollar amount? $4.01, right? So if I were you, I would make my stems, and I would actually write my stems this way. I would make my stems starting at 3.7 and go all the way to 4.0. So you got 3.7, 3.8, 3.9, and 4.0. You'll have four stems that way. And then your leaves are your last penny. So when you do your key, you'll do your key. So it looks like, well, if we're doing 371, you'd have 3.7/1 equals $3.71. So 3.7/1 equals $3.71. So that's how you'll deal with that one. Then question 2, which is hole punched out of here. Question 2 says what? Of the calls made above. So now we are going to find not mean, median, mode, just mode and median. Which is easier? The mode. So what is the mode? What's the mode, Misha? Is there always a mode? There might not be a mode, right? Could there be more than one mode? Yes. Is there more than one mode here? Yes. So look at your leaves. Which leaves appear the most often? The doubles there. Oh, here's triples, right? So we have triples here. And we have triples here, right? There's no quadruples, is there? Are there any other triples? You can't just say the mode's 2 and 4. Is that correct? Nope. So the mode equals what? 12 and 14, because it's coming from the stem of 1. The median is a little bit more difficult. How are we going to find the median?
You add them, like you go from lowest to the highest and you cross them off and denominator.
Okay, that's the second easiest one to find, isn't it? The mean is the pain in the butt. What do you have to do for the mean? Who wants to tell, for the mean? Who wants to tell us? Right, so the mean would be adding up all 30 numbers and dividing by 30 because we have 30 data items. Well, they're not asking you that for here, they're asking for the median, but be really careful in your stem and leaf plot. You need to go from small to large, and you can think of it this way. How many pieces of data do we have? 15. If I were you, because some teachers will teach you to go this way and go in, but on a stem and leaf you can get really confused as to what starts where and that kind of thing. So if I were you, I would go, okay, I have 30 pieces of data. Half of that would be what? 15. Is there one middle piece of data or 2? There's 2. So what do you do in that case if there's 2 middle pieces? Well, let's find where the middle is. So count 15 out. 1, 2, 3, 4. And then we have to go back to the left. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Here's the 15th right here. Doesn't that cut the data in half between 21 and 22? Isn't the median the average of those two? 21 plus 22 divided by 2? What number would that be? You can use your calculator, but use your brain. What number would that be? 20 what? Mm-hmm. What number is directly in between 21 and 22? 21 and a half or 21.5. So there's your median and there are your modes. And so you'll do the same thing over here for the data that you're going to make for that one. Then jump down to 3 and 4. This time you're going to create a dot plot. A dot plot, we're going to use dots. You might have used X's in the past, especially if I use graph paper, I tend to use X's. I don't care if you make a little X or a dot. It really makes no difference to me. I kind of prefer X's because they're a little bigger than dots and you can kind of get them the same size, but some of you will have different size X's, which is also another problem. So maybe we'll use dots. So we have another situation here. We got the growth in centimeters of a certain variety of plant after 20 days is shown below. The difference between a stem and leaf and a dot plot is we have to have every number included in the range on your dot plot here. So what's our lowest growth in centimeters? Appears to be 12, right? What's our highest? 59. There's nothing in the 60s, right? So we have to arrange, our range is going to go from 12 to 59. So I have to get numbers from 12 to 59 along here, because I might have a dot for every number from 12 to 59. And I have to be able to put the dots side by side. I can't have a dot of 12 and another dot above 12 that represents 14. I can't do that. So how far apart is 12 and 59? Take your calculator and take 59 and subtract 12. We have to have a range of 47. So my suggestion would be to pick a nice happy number that's a little lower than 12 and a nice happy number that's a little bigger than 59. So what do you want to go from what to what? 10 to 60. Okay? So 10 to 60, 60 minus 10 is what? 50. So you have a range of about 50 there. So we can do little hash marks, but you have to be able to, where'd my ruler go? So let's measure our line here. And I'm actually now need a ruler because I have to partition this in nice equal pieces. So my line is approximately 7.5 centimeters, right? If I go by tens, I would only split it into like about 5 pieces, right? So I probably don't want to go by tens. I might want to go by 5s, right? So if I start here at 10, and I go increments of 1/2 of a centimeter, I would have 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. It's squishing it just a little bit, isn't it? So I actually have 7 plus 5. I actually have 75 millimeters, don't I? All right, so let's take our 50 numbers. I've got 75 millimeters, so I'm going to divide it by 50 numbers. So about every 1.5 millimeter. So let's go every 2 millimeters. Let's see what happens. So if this is my 10, there's 11. Well, let's go ahead and partition it this way. Let's see what happens. That should hopefully spread us out enough. Because I really don't want to go 1.5. So maybe instead of starting at 10, we could start at 5, 10, 15, 20, 25, 30, 35. Oh, that won't work. So start at 10. We're going to solve our issue right here. What am I going to do? I'm going to extend my line. So if this is 10, this is 15, 20, 25, 30, 35, 40, 45, this is 50. And then how far do I have to go? To here? So 55 and then 60. Will that work? Right? We can get all our numbers in there. Not only do I have to have a title for this plot, I also have to label what do those numbers under there mean. So let's just start with our title. What is this data going to represent? Growth of a plant after 20 days. Or over 20 days is probably what I would put. So growth of a plant after 20 days. I don't know how high I'm going to have my room for my dots, but I can pretty much guarantee you usually it's not going to go way far up. And then what do these numbers here represent? Like what's 59 represent? What does it mean? 59 what? Centimeters. So this is growth in centimeters. So you do have to label that bottom axis, that line, number line. What's nice about this is I don't have to have any interim work. I don't have to use my own personal graph paper for this one at all. I can just start putting dots on here. And I'm going to put my dots wherever they go. And then if I have a dot that's not one of these hash marks, I have to make appropriate hash marks in between for that dot to go. So you'll see me doing that. So 20 is actually right here on the line. So there's my dot. Try to make your dots all equal dot size. So I'm going to cross out my 20. Then I'm going to go down. So I'm going to do 43. Well, 43 isn't one of these. This would be 41, 2, and 3. So I'm going to put a dot right here at 43. I don't have to label it because I've put my little hash marks in there. I'm going to cross out 43. Then I'm going to do 53. So same thing. 1, 2, 3. So there's 53. And then keep going. Now, once you hit, 39 we didn't get again. What's your first repeated value? What's your first repeated value? Do we get any repeated values? 38 and 59, right? So when you get there, look at my graph. So at 38, your second 38, you now put a dot above the dot. And when you stack your dots, just like on the stem and leaf plot, you want to stack them equal distances apart on all stackings. So when you're done with your dots, you want to count your dots and make sure that you have 20 dots. So I have my 20 dots. So the data appears to be fairly stretched out, but it seems to be congregating more towards the right-hand side of the graph. Can you easily see modes here? Could you easily find your median here? Yeah. So look what the next question down below says. Find the mode and the median growth after 20 days. So we're going to do the same thing. So what are our modes? Where do you see, what's the highest stack? Is there more than one? Okay, here's one here, right? Here's one here, here, and here. So we actually have 4 modes, don't we? So our mode is equal to, what's this stack represent? 38. So I'm going to put 38 centimeters. What's this stack represent? 43 centimeters. You have to attach that unit of measure to it. What's this one represent? 53. Why would they like those 3s? And this one, 59. And then we're going to find our median. So the median is the middle number, right? Is there one middle number, or do we have to average again? One middle number or an average? Average. So take 20, divide it by 2. That means there's 10 dots on the left and 10 on the right. So start counting your dots. 1, 2, 3, 4, 5, 6, 7, 8, 9. The 10 occurs in here, doesn't it? Between those 2 dots. Well, if they're the same dot, do we have to average it? Because that's 43 and 43. If you add 43 to 43 and divide it by 2, won't you get 43? There is no number in between 2 43s, so the median is 43. So 43 centimeters. Now on this one you've got decimals. So if I were you, how might you set up this? You're going to find your lowest and your highest, right? What's your lowest? Yeah, it looks like 7.2, right? What's your highest? 11.2. So you have to go from really essentially 72 to 112, don't you? And that's how I would look at it. Go from 72 to 112, and then you just make sure you put points in there. So instead of writing 72, you'll write 7.2. But still think of it in terms of when you're putting in 73 in there, you're going to have like 7.0 here, and you'll count 1, 2, 3, and there will be your 7.3. So try that and see if that makes sense. When you look online for the answers, you'll see what I put on there. So flip this over. So for this one, I'm going to have you do most of this on your own. They've given you the stem and leaf plot. It's nicely well done. It's got a key over here. It's asking you for the best test score, how many students took the test, what's the median, and the percent, what percent of test scores are above 73. That's the hardest question right here. This one right here. And then you have to describe the distribution. Well, I'm going to help you describe the distribution. It uses this thing called SOX. So you need to write yourself some notes on here as to what SOX means, because that's probably super new to you. Anybody ever heard of SOX when describing a graph? I thought not. All right, so let's go ahead and write some notes on here as to what that means. So the S in SOX means I want you to describe the shape. We'll talk about that in a minute regarding this graph above. The O represents outliers. We'll be more specific about outliers further on. For right now, we'll talk about them in generalities. The C represents measures of central tendencies. So I'm going to put here central tendencies. So mean, median, and mode. You always want to talk about mean, median, and mode. So you might want to put here M, mean, median, mode. And then the second S is your stretch, which is another way for saying range. So shape, outliers, central tendencies, stretch, SOX. So that will help you remember it. So we're going to go through that, and we're going to describe this graph. So as you look at it, kind of turn it this way. What do you notice about its shape? Is it evenly distributed? Is it skewed to the right, skewed to the left? What do you notice about it? How many pieces of data are there in there? Let's start there. Count your number of data items. Right? All right, so where does most of the data seem to lie? To the right, so let's just count here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Isn't that almost 2/3 of the data? So you're right. I would say that the data seems to be skewed to the right. It's not highly skewed to the right. It's not obvious. It's not like the graph is going up like this, right? But that's what we're going to mention in here. So we're going to say instead of saying the data, I want to talk about what the data means. What does that data mean? Test scores. So test scores, and we have to use complete sentences. Test scores appear to be skewed. Learn how to spell that word. Don't spell it wrong. It could be embarrassing. Skewed to the right. Outliers are things that are obvious highs and lows. I'll teach you how to find the exact definition of an outlier later. But for right now, just know that they're obvious highs and lows. As you look at this data, does there seem to be any kind of freaks of nature data? Like, what's the lowest test score? 61, and the highest test score is 100. But don't we have, we have two 100s, we have two 99s, 98. Aren't those all fairly close to each other? So there's really no outliers when it comes to the high test scores. What about the low test scores? Are there any kind of really far away low test scores? No. So I would put in here, there are no obvious high or low test scores. Then you need to talk about the measure of central tendency. I rarely would use the mode as a measure of central tendency. So which is easier to find, the median or the mean? I would probably use the median. And since there aren't any obvious outliers, the median or the mean are going to be fairly close to each other. Once we have outliers, outliers will affect your mean, so you would want to go with your median. But in this case, it doesn't matter which one, so since median's easier, I'm going to choose that. So we're going to find the median test score. We have 30 test scores, so count to 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Splits right here. Don't we have to average those two numbers? Lucky for us, aren't they the same number? So what's the median test score? 86. So we're going to write that here, the median test score. And you have to tell what measure of central tendency you're using. Median test score is 86%. And you can even say, with your, well, we'll say this next. So with our stretch, our range, I'm going to talk about the fact that test scores ranged from what to what? So test scores range from what to what? 61% to 100%. And that's all you have to say. So if you use your socks, you'll be good to go. So just remember socks. Shape, outliers, central tendencies, stretch. And that'll tell you what to write. You don't have to think overly much about it, but do use complete sentences. Talk about what that data is. Don't use pronouns, it, or the data, or they, or anything like that. You have to use actual nouns. Okay, so then we're going to move to 6 and 7. So for 6 and 7, you have to find the mean, median, mode, and range for each data set. You are allowed to use your calculator. Please use your calculator, but I want to see how you get it. So the first thing I should do is what? Order them from smallest to largest. So that's the very first, even though I don't need to do that for the mean, I need to do that for median, and it helps us to see mode. So what's our smallest data in number 6? 66. So cross it out. So make sure that you ended up with 6 pieces of data. So on this one, again, we have an even set of data. I will tell you on number 7. Number 7 has an odd set of data. So on number 7, when you order this one, the middle number is going to be one number you won't have to average. So on this one, if you have 7 pieces of data, what's going to happen? How many pieces of data are to the left of the median? 3, and 3 to the right. So the 4th piece of data on this one is going to be your median. All right, so look here. I don't care which one you put down, so let's go ahead and start with the easiest, the mode. What's the mode? There is none, right? So you have to physically put none. The median? So there's 6 pieces of data. Take 6 divided by 2, what do you get? 3. So 1, 2, 3. This cuts the data in half. But this time, I mean, you could reason your way and say what a number is exactly between 84 and 90. You can definitely do that. But this is really what you're doing. 84 plus 90 divided by 2. You're adding them together and dividing by 2, you're averaging. So on your handy dandy calculator, 84 plus 90, you can't see that, is 174 divided by 2. You better get a number that's between 84 and 90. If you don't, you did something wrong. Does 87 seem reasonable? Okay, so that's our median. and then our mean, I expect you to add up the numbers and tell me what's in your numerator. I want to know what you're putting into your calculator. So you could either, I don't expect you to write them all out because that's could be really long for some of these, but I want to know what the sum is. So I'm going to add these numbers together. So I get 60, 66, plus 78, plus 84, plus 90, plus 102, plus 114. Did we all get 534? Yes, no. All right, so I'm going to put 534. What do I divide that by? Why 6? Because there's 6 pieces of data. So I'm going to divide that by 6. And I might get a decimal. This case I didn't. If I got a decimal, round to 2 decimal places. So here I get 89. What do you notice about your median and your mean? Are they close to each other? Very similar. What do you notice about outliers? Do there seem to be numbers that are really far apart from your lowest, and are your lowest and highest really far apart from the rest of your data, or are they generally close together? Generally close together. That's why your median and your mean are the same. Now what you're going to notice about this data, isn't it exactly the same, but they've added what? 200 to it. Is 200 far away from 114? 200 is an outlier. You're going to see that that outlier is going to affect your mean. So the questions below down here are going to compare your results for 6 and 7. So I want you to use your best brain and try to answer these questions, okay, based upon that. And then let's talk about these ones down here. So these are thinker questions. So 10, 11, 12. The mean of 3 numbers is 14. If 2 of the numbers are 7 and 10, what is the third number? Here's what I want you to do on these. So I'm going to do one of them, and I want you to do the other one exactly the same way. So split your paper, or split your question here into thirds. Okay? You're going to start to do word problems exactly the same way, 100% of the time. So this first one is called your let statement. You're going to let x equal, because we have an unknown. What is it you're trying to find? What is it you're trying to find? The third number. So that's what you let your variable equal. We're going to let x equal the third number. Then we have to set up an equation to solve. It says the mean. How do we find the mean? Add up your numbers and divide by, in this case, 3, because aren't there 3 numbers? The mean of 3 numbers. Did they give you any of the numbers? Yeah, 7 and 10 right here. So to set up my equation to solve, wouldn't I take 7 plus 10 plus what? X, your third number. We don't know the third number. We're going to say it's x. All of that gets divided by what? 3, because we have 3 numbers in the mean. If they'd given us 5 numbers, we'd divide it by 5. Do we know what the mean is? They told us it's 14. That's an algebraic equation that you can solve. However, we have a fraction, so it's a little bit difficult. Some of you, a lot of you in here have really horrid solving skills. In other words, you're showing your work wrong. So please watch what I do. So my x is in a fraction. It's in jail. I want to get rid of the fraction. How do I get rid of this fraction? What's the denominator? 3. This whole thing is being divided by 3. What's the opposite of dividing by 3? So to get rid of that fraction, I'm going to multiply this side by 3 and this side by 3. You have to show what you're doing to both sides. Is everybody listening? You're not writing. So I'm going to cross out my 3's, and I'm running out of room, so I'm going to put the rest of this over here. What's 7 plus 10? So can I write that as 17 plus x equals, and then you need to multiply 14 times 3. 3 times 4 is 12, carry the 1. 3 times 1 is 3, plus 1 is 4. So isn't 14 times 3, 42? Now what do you do to both sides? Now what do you do? Yeah, and I have to see you subtracting 17 from both sides. You cannot do it in your head. You cannot do it to one side, and that's what some of you are doing. Then I get x equals 42 minus 17. I get 25. What does X represent? Did I answer the question? But you have to answer it in a complete sentence because that's what Park wants you to do. You're going to use the word therefore. Therefore, because it makes you sound really smart, the third number is 25. Now, number 11 is just like what we did, but this time you have 4 numbers. So what are you going to divide by? 4, right? And then number 12 is I want you to create your own set of test scores that has a range of 73 and where the mean is smaller than the median, so you have to play around with it a little bit. I want you to have a minimum of 10 test scores, okay?